Okay, a question like this, have a look at what's happening. We've got a carbonate, an acid, against salt, carbon dioxide and water. So over a period of time the mass goes down. Here we've got to think about the state symbols. This will be aqueous, this will be gas, this will be liquid. So we're losing gas. Yep. So carbon dioxide will be lost as time goes on, so the mass will go down. Okay, an excess of strontium carbonate is mixed with 20 centimetres cubed of that concentration of nitric acid. Calculate the mass of strontium carbonate that reacts. So we know it's an excess, so we need to know how much reacts. So go back to the equation, notice that it's a 2-to-1 ratio between these two. So let's work out how many moles we have of the nitric acid. Okay, so just get my calculator. Okay, so I got 20 divided by 1,000 depending cubed times by the concentration gives me that number of moles of nitric acid, and I'd have half the number of moles of strontium carbonate. That would react. There will also be some that don't react. Okay, but we want a mass, so mass equals moles times by molar mass. So we've got to make sure we got the right periodic table. And we can see that strontium is 87.6. So we've got 0.0125 times by 87.6 plus carbon, which is 12, plus 3 lots of 16, which equals 48. Okay, so add those together. And we get 1.845 grams. Right, the student plots a graph of total mass reagents contained against time. So, things to have a look at here is notice that the axis doesn't go to 0. Okay, the lowest it goes is here. But you can see that as time goes on, the mass is going down, isn't it? Because we're losing CO2. It goes down most steeply here at the beginning of the reaction, and then it starts to level off here. So we're not losing very much mass when we get to about 400 seconds. So what's the question want us to do? Describe and explain the change in the rate of reaction during the first 200 seconds of the experiment. So let's have a look at the first 200. It's up to here. Okay, so we can see that the initial change in the rate started off very fast, and then as the gradient, see here, gradient's very steep there, and as we go around, the gradient is getting less and less and less steep. Okay, we've got to describe it. So the gradient starts very steep. At t equals 0, the initial time, and then it gets less steep. Now why would that be? So you've got to explain. The rate is decreasing. Why is the rate decreasing? Because we're using up reactants. The concentration of reactants decreases during an experiment, and so there's less collisions. Use the graph to calculate the reaction in grams per second at 200 seconds. Show you're working on the graph. Right, so this is drawing a gradient. So I've got my line, probably should draw it a bit better than that. So at 200 seconds I'm going up. And where that line meets the graph, I've got to put the gradient on. So let's put my ruler, and I'm trying to, don't want to cross the line. I want to draw my line, not so it goes over the graph, but so it's touching it, but only just. And so it's not like that, okay? That's going over the line. It's got to just touch the line. So it's about, come away a little bit to give myself room to get my pen. I should do it with a pencil really, but I'm going to do it with a pen so it shows up on the video. And then I'm going to draw a line there. Okay. Now, this from here to here, the bottom of that triangle, is what we call difference in x, dx. It goes from 0 to 300, so it's 300. Then from here to here is dy. You've got to be careful here because we're not starting at 0. So we end up at 96. What was that? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So there's 96.8. We started off at 95.90. So 96.8 take away 95.9 equals 0.9. Okay, that's my dy. So now I'm going to do dy over dx. So dy over dx, which would be 0.9 over 300. Okay, so that's what we're going to put here. 0.9, which is my grams, over 300, which is my seconds. That's why it gives me grams per second. Sorry, squared. 1 per second. Okay, so we'll take my 0.9. 0.9 divided by 300 gives me 3 times 10 to the minus 3. Okay. Outline a method that can be used to obtain the results that are plotted on the graph. Your answer should include apparatus required and a procedure for the experiment. So let's think about this. One thing we're timing, so we're going to need some sort of stopwatch, stop clock. We've been measuring a change in mass, so we're going to need a balance. We're looking at the graph to 2 decimal places. We're going to need container for this reaction. So probably best to have a conical flask. That way, if there's any effervescence, fizzing, any spitting, it's not going to come. The liquid isn't going to spit out of the beaker because of the slope size of the conical flask. The reaction stays in there. Okay, so we're going to need to have. We're going to have the acid, or we have the carbonate in the flask. You're going to add the acid and start the timer. Record the mass we're going up to 400, so I'd say every 50 seconds. Oh, sorry, you didn't have to be 30 seconds, whichever, and then done it for 400 seconds. Okay.